All right, let's jump straight into this explainer and check out a seriously fascinating new tool that's kind of changing the game for machine learning researchers. We're looking at a project called Train Assistant AI, built by Argadeep Akira. Listen, if you've ever trained an ML model, you already know that the journey from raw data to a fully optimized model is, well, it's never a straight line. It is a grueling, iterative grind. So today we're going to unpack exactly how Train Assistant AI acts as this incredibly smart, agent-based assistant. It uses tech like Google Gemini, FastAPI, React, and this really cool thing called the Model Context Protocol to completely flip how we understand training behavior and spot optimization issues. Let's get right into it.
Is my model overfitting? It sounds like such a simple question, doesn't it? But actually answering it is usually anything but simple. Training deep learning models is just notoriously trial and error. I mean, think about the intense frustration, the absolute pain of just staring at walls of raw terminal logs, all just to answer that one single critical question. You know the drill. Researchers run dozens of experiments, tweak tiny little parameters, and then suddenly you're completely lost in a sea of raw numbers and static charts, desperately trying to figure out if your model is actually learning anything or just, memorizing the training data.
And the reality is, it's never just one question. It's a massive avalanche of questions. I like to call it the trial and error trap. You're constantly asking yourself things like, okay, which epoch should I actually restore? Wait, why did my validation performance just completely flatline? Out of these 10 experiments I just ran, which one is actually the best under the hood? Or even, what hyperparameters am I supposed to tweak next? The real tragedy here is the time sink. Researchers end up wasting so many hours manually analyzing logs just to answer these basic questions, instead of doing what they really want to be doing, building better models.
So the absolutely crucial point here is the paradigm shift. Traditional dashboards, they just give you passive graphs, passive numbers. Sure, you can watch a line go up or down, but the dashboard doesn't actually explain what those metrics mean or tell you what you should do about them. And yeah, a standard AI chatbot might be able to explain basic ML concepts, but it can't actively inspect your specific training logs. Train Assistant AI completely flips the script. It provides active reasoning, it actually executes tools, and it gives direct, concrete recommendations. It doesn't just chat with you about machine learning, it's actively acting as a diagnostic detective.
Section 1. The Diagnostic Detective, Part 1. Training Analysis. Let's see this in action.
Let's say we have a 25 epoch training log. We'll call it run_a.csv. You drop it in and ask the AI to analyze it. Boom, the agent springs into action. It reads the file and fires up its diagnostic tools. It's not just lazily plotting a graph, it's deeply analyzing the numerical trends epoch by epoch. And almost instantly, the system pinpoints epoch 12. It spots that validation performance was steadily climbing right up until that exact moment.
At that precise epoch, the AI catches something absolutely crucial. The model hits its peak metric, its absolute highest validation AUC of exactly 0.918. But what happens next is the key. The agent keeps analyzing the later epochs and sees that while the training loss keeps dropping, the validation loss actually starts to climb. The AI nails this diagnosis. It's classic overfitting. Plus, it notices the validation performance completely plateaus after epoch 12, and even points out that dropping the learning rate later on didn't do a thing to help.
And this brings us to what I think is literally the most powerful part of the whole system. Instead of tossing a chart your way and making you guess your next move, the agent explicitly gives you the fix. It says, the assistant recommends restoring the checkpoint from epoch 12 and stopping training earlier. It tells you exactly what the metrics mean and exactly what to do. The guesswork, completely gone.
Section 2. The Diagnostic Detective, Part 2. Experiment Comparison.
Because let's be real, in the wild, you never just have one run. Imagine throwing that previous file in right alongside a brand new log, run_b.csv, and simply asking, hey, which one did better? The assistant goes way beyond just looking for the biggest number. It evaluates the peak validation AUC, the validation loss, how stable the convergence was, and how bad the overfitting got. It breaks it all down and shows that while run A hit a 0.918 AUC, run B crushed it with a 0.939. Based on the whole picture, the assistant confidently crowns run B the winner. Stable convergence, lower loss, better performance. It does in seconds what would take a human forever to cross-reference manually.
Now, the so what here is huge for your day-to-day workflow. When it's done analyzing, the agent automatically whips up these highly detailed markdown reports. We're talking a full summary, best epoch, best AUC, all the diagnostic findings, and those concrete recommendations. But it actually goes a step further and generates full visualizations right into the report using Pandas and Matplotlib. You get these gorgeous, ready-to-go loss curves, AUC curves, and learning rate schedules. It's a perfectly formatted, shareable report that saves literally hours of manual grunt work.
Section 3. Under the hood, the architecture. Let's see how this actually works. To understand how this agent perfectly bridges the gap between thinking and doing, we have to look at its 4-part tech stack, which is heavily built on TypeScript. First up, you've got the React frontend. That's your conversational UI. Then, the FastAPI backend handling all the request traffic and file uploads. Third, you have Google Gemini stepping in as the heavy-duty reasoning engine. And finally, component number 4, the MCP-based server, which holds all those specialized ML diagnostic tools. It's a beautifully clean setup that totally separates the user interface from the complex AI logic.
Now, this right here is the absolute secret sauce of the whole project, MCP, or the Model Context Protocol. When you ask a question, Gemini uses MCP to figure out exactly which tools it needs to use. Maybe it needs to run a log analysis, check for a plateau, or monitor GPU stats. Gemini calls those tools through the MCP, processes the results, and then builds its final recommendation. This protocol is the bridge. It lets Gemini interact with highly specialized tools while keeping the execution entirely separate from the reasoning. This is what officially upgrades Gemini from a simple chatbot to an active, independent ML agent.
So, what's the big takeaway from all of this? It's a fundamental shift in how we handle our data. Train Assistant AI isn't just regurgitating numbers. It is interpreting them. By mixing Gemini's reasoning with those MCP-powered tools, the system actually transforms raw, messy metrics into crystal clear, actionable insights. It slashes your debugging time. It pulls you right out of that brutal trial and error trap.
Which leaves us with one final thought to chew on. If Train Assistant AI is taking over the heavy lifting, if it's checking convergence, flagging overfitting, and writing your reports for you, you suddenly have your time back. You aren't stuck staring at terminal screens. So the question is, what are you going to build when you're finally free from the manual debugging grind?